Okay, going to finish up with that second system by going through row reducing its corresponding matrix. And so the matrix for this system, the matrix for this system would be 3, 1, negative 3, and 1, negative 1, negative 5. And there it is, 3, 1, negative 3, 1, negative 1, 5. Now since our first objective is to get a 1 in the upper left corner, we can do that with this one simply by interchanging the rows, and that's the notation for that here. So we move row 2 down to, or row 1 down to row 2, and row 2 up to row 1, and you now have your 1 in the upper left corner. Now the next step is to get a 0 in the lower left in row 2, column 1. And so since that entry is 3, we make that 0 by adding negative 3 to it. Where do we get a negative 3 from? We get a negative 3 by multiplying the first row by negative 3. And that's what we've done here, is negative 3 times row 1. Negative 3 times 1 is negative 3. Negative 3 times negative 1 is positive 3. And negative 3 times negative 5 is positive 15. Excuse me, then we add this product to row 2 right here. Negative 3 plus 3 is 0. 3 plus 1 is 4, and 15 plus negative 3 is 12. And then that becomes our new row 2. We place that in row 2 because that's where we want the 0 in the first entry. Next, in this bottom middle entry, we want a 1. And since it's divisible by 4, we multiply that row by 1/4, and that will give us a 1 in that second entry of the second row. So 1/4 times row 2 is our new row 2, and that's the notation for that operation. And finally, the last thing we need is a 0 in the second entry of the first row. And since the corresponding entry in row 2 is already the additive opposite, or the additive inverse, which is the opposite, then we just add those two rows together, row 2 plus row 1, and that will give us 0 plus 1 is 1, 1 plus negative 1 is 0, and 3 plus negative 5 is negative 2. And that will become our new row 1. So row 2 plus row 1 goes into row 1, and that gives us the reduced row echelon form of the matrix, which therefore tells us that our solution is x equals negative 2 and y equals 3, which is what we have up here. And finally, the last system, you will notice, if you've worked on these questions, you will notice that this is not the same system that was on the practice exam I handed out. The practice exam I handed out, both versions, both the first one and the revised version, have a different system, and it certainly can be reduced, and you will get a solution, but it will have fractions, and I don't intend, I mean, you should certainly be able to work with fractions, but I don't intend to make you do that on an exam. There's already enough anxiety in taking a math exam, so I don't want the very hardest questions. I never ask the very hardest questions for any exam. So I've changed this to a more easily solved system. It's still a bit of a challenge, but if you solve it using substitution or using matrix methods, but it can be done without having fractions for an answer. So anyway, to solve this by substitution, I have chosen to isolate x in terms of y in the first equation. So I add 8y to both sides of the equation, so I have 5x is equal to 3 plus 8y. Then I divide both sides of the equation by 5 or multiply by 1/5. It's the same operation, same thing. And I come up with x equals, in the numerator, 3 plus 8y divided by 5 in the denominator. So that's my that's my x in terms of y, and I substitute that into the other equation. So where I have an x here, I place a set of parentheses, and inside those parentheses, then I substitute this expression, 3 plus 8y, over 5. And when I multiply and when I solve for y, of course the first thing I need to do is to clear the parentheses by multiplying the 2 across. And so I've made these two separate fractions. 2 times 3 is 6, and here's the 6 over the denominator 5, the common denominator 5. And then 2 times 8y is 16y, and that's my second fraction, 16y over 5. I've split this into two terms. Now, in order to isolate a single y, because I have fractions, the most efficient way to isolate that y is to first clear the fractions. And I can see that I can do that by multiplying each of these fractions by 5. Of course, that means I have to multiply everything by 5. So I multiply all 4 terms here by 5. 5 times 6/5 gives me 6 because the 5's cancel here. 5 times 16y over 5 gives me 16y because the two 5's cancel there. And then 5 times negative 3y, and don't forget to multiply times the other terms. Multiply by everything. So 5 times negative 3y is negative 15y, and 5 times 2 is 10. And when I collect my like terms, 16y minus 15y gives me a single y, and 10 minus 6, so I subtract 6 from both sides, and so I have y is equal to 4. Now I substitute that value into y for either equation. I have chosen to do that in the second equation. And so wherever I had a y, which was right here, 3y, I put a set of parentheses, and in those parentheses I place the 4. And negative 3 times 4 is negative 12, so I have 2x minus 12 equals 2. I add 12 to both sides, that gives me 14, so I have 2x is equal to 14. Divide both sides by 2, and I have x is equal to 7. And now here's probably the best way to solve this system is by elimination. Now, in order to make one pair of terms, the x terms or the y terms, the additive inverse or the opposite of one another, I need to perform 2 multiplications. And I've chosen to multiply the first equation by negative 2 and the second equation by 5, because that will make the x terms the additive inverse of one another. So negative 2 times the entire first equation is negative 2 times 5x is negative 10x. Negative 2 times negative 8y is positive 16y. And negative 2 times 3 is negative 6. Then multiplying the second equation, the entire equation by 5, I have 5 times 2x is 10x. 5 times negative 3y is negative 15y. And 5 times 2 is 10. Now when we add these equations together, the negative 10x and the 10x cancel each other out additively, and the 16y plus negative 15y gives me a positive y, just one y, and when I add the negative 6 and the 10, I get y is equal to 4. Now exactly as we did here in solving by substitution, you can substitute that value of y into either equation and solve for x, and when you do, you'll have a value of 7. And now finally I will go through row reducing the corresponding matrix. And so the corresponding matrix, as you can see, is 5, -8, 3 in row 1, and 2, -3, 2 in row 2. And since my first goal is to get a 1 in the upper left corner, I multiply that row times 1 over 5. And so when I multiply that row times 1 over 5, of course 1/5 of 5 is 1. And then this -8 becomes -8 over 5, and this 3 becomes 3/5. Now, since I need, and there's the notation for that, row 1/5 row 1, it goes into row 1, becomes a new row 1. And now, since my next step is to get a 0 here, I want to add -2 to it. And remember, this is why you put a 1 in the upper left corner, so that you can then use that row to work on that entry without disturbing anything meaningful. So I need a -2, so I multiply -2 times that first row. -2 times 1 is -2. -2 times -8/5 is positive 16/5. -2 times 3/5 is -6/5. Now I want to add, and that's -2 times row 1. Now I want to add that to row 2 to eliminate that entry there in the first entry in the second row. And so -2 plus 2 is 0. I have converted -3 to -15/5 because they have to have a common denominator, these two fractions do, in order for me to add them up. And so I've converted -3 to -15/5 by multiplying -3 times 5 and then putting that value over 5. And then I multiply 5 times 2 and put that value over 5 to give me 10/5. And so when I add 16/5 and -15/5, I have 1/5. And when I add -6/5 to 10/5, I have positive 4/5. And so now that becomes my new row 2. I've multiplied row 1 by -2, and I've added it to row 2, and that is my result there. And that result becomes my new row 2. Now the next step is to get a 1 in this entry here, the middle entry of the second row. And so to turn 1/5 into 1, I multiply it by 5. And that's the notation for that right here. 5 times row 2, and that will become my new row 2. 5 times 1/5 is 1. 5 times 4/5 is 4. And so now I'm back to integer entries in my second row. And now the next step, the last step, is to get a 0 in the second entry of the first row. And to get a 0 there, I have to add 8/5. Well, again, this is why you get a 0 here and a 1 here, so that you can then use this second row to manipulate the first, and the 0 here will allow us to not disturb that first entry. And so since 8/5 is the additive inverse of -8/5, I multiply the second row by 8/5. So that's what we're doing here. 8/5 times row 2 is 0, 8/5, and 32/5, because 4 times 8 is 32. And then we add those two rows together to knock out that middle entry. And so 0 plus 1 is 1, 8/5 plus -8/5 is 0, and 32/5 plus 3/5 is 35/5. There's the notation for that. 8/5 times row 2 plus row 1 is 35/5. Well, 35/5 just happens to be 7. And so that's our new row 1, because it's got a 1 in the first entry, a 0 in the second, and a value in the third is the is the value of x in our solution. And here's the notation for that last operation. 8/5 times row 2 plus row 1 becomes our new row 1. And this is the same solution that we saw before when solving this by substitution. xy is equal to 7, 4. X is 7, y is 4 is the solution to the system.